Power grids cover huge distances, and even a small fault in a transformer or insulator can disrupt electricity for thousands of people. Yet most inspections are still manual, slow, and often dangerous. Computer vision changes this by turning images and drone footage into automated checks that highlight issues instantly. What you're seeing here is a model detecting a power transformer and an insulator in real time. Exactly the kind of capability that makes large-scale monitoring possible. In this video, you'll learn how this technology works and how you can train your own computer vision model to inspect transformers, insulators, and other critical grid components. If you want to automate power grid inspection with AI and make the entire process faster and more reliable, this tutorial will give you a complete starting point. If you enjoy our content and want to see more, don't forget to hit subscribe.
Hello everyone, welcome to this computer vision tutorial. In this tutorial, I am going to show you how you can use computer vision for power grid inspection. As you know, power grid are one of the dangerous place is structural monitoring, and there are lots of chances of any mishap happening. So why don't we use computer vision to solve this issue, like using a drone? Let me show you a video. Why don't we use drone to inspect the power grid, like these generator, or you can even use this to inspect the insulator here. So in this tutorial I will show you how you can train a model to inspect these object using computer vision. First of all, you need a data set of the object you want to detect. So I have few videos of power grid. So on this video I'm going to train our model. So to train our model, first of all you have to load this data set in our labeler platform. I have loaded this data set on our labeler platform, and now we just to provide it with the classes. Like these are the classes I have chosen, like power transformer and insulator. So here are the insulator. So you just have to select each one by one. And when all the objects in a frame has been annotated, you just have to run SAM2 on it. So when the SAM2 will be run completed, it will annotate your whole video. So you will get something like this. Your whole video has been annotated. Now before continuing our video, can you answer this simple question? Which step come first when training any computer vision model? A. Hyperparameter tuning. B. Data annotation. C. Exporting the trained model. D. Model evaluation. You can answer yours in comment section. You will just have to repeat this process for every video in your data set. Then you can train your model. So when the annotation of this video is completed, you just have to accept it. Then after the annotation of all video dataset has been completed, then you just go to files and export your dataset annotation. So in JSON format, you just have to export it and download it from here. Now let's get to our next step. When you will download your annotation, it will look something like that. As you can see, it has the file name, file ID, and then here is the annotation of the object for a single frame. So with this, you can train your model. So I am going to use YOLO model. So first of all, you have to convert this annotation into YOLO format. For that, I have created a library which you can use. You just have to clone it. And from that library, you just have to use a function function called convert to YOLO segmentation. In that function, you have to provide the annotation part, which is the annotation JSON, and the videos directory part, which store your all sample video. Now you just have to use split true, and it will divide your dataset into train, valid, and test dataset. So now let's run it. I have around 500 images for training. So let's wait. So your YOLO dataset has been created. As you can see, it has two classes, and for training set, there are around 400, 500 images. For val, there are around 367 image. For test, there are around 367 image. Now, it will look something like that. There is your image folder, there is your images, then there is your labels. In each label, there is the annotation you will found. So now for next process, you just have to first clear your GPU so you will have sufficient VRAM for model training. Now you will start by choosing the model you want to train on. I am using YOLO 11S segmentation model for segmentation detection. So now just use YOLO from Ultralytics, and in that provide the name YOLO 11S segmentation. Now to start training, you just have to use model.train and provide the part to data.yml, which is this file which we have created. As you can see, this is the path. You can comment it out. Now you can start your model training. As you can see, the model training has been started. I have already done that. It will took me around 2 hours to train a model, so I am not going to do it again. So now let's load our model. Best model. This is the best model I have trained. So this is the best.pt file, which is your fine-tune model on your custom classes data. So you just run this. Now let's take a sample inference. I'm using a frame of the video to test its inference. As you can see, it detected four power transformers here. Now let's run this on a video. As you see the video, the model has worked perfectly in detecting the power transformer class. So let's get to our next video and see its results. So for that, let's use a frame as an example. It is that video which we have annotated our data. As you can see, it has detected all the annotated insulator perfectly. Now we just have to run it on a video. Let's see its video inference. Here also model perform greatly in detecting the insulator class which we have annotated. So let's see an example where the model has been failed somehow. Let's check it out. Like this is the video frame I am using. As you can see, it has failed to detect this insulator, and it has detected here two bonding boxes. As you can see, these bonding boxes are overlapping. Let's see in this video. As you see the inference, the model were somewhere inconsistent and unable to detect the insulator class. It has also seen some overlapping. These occur when the model has been not trained on a large diverse data set. I have only trained it on a 3 video, so that problem may occur. You can solve it using training your model on a large diverse data. With that, now you know how you can train your own computer vision model for grid inspection. You can also check our other videos like how you can fine tune YOLO on custom dataset or how you can build a real-time intrusion detection system with YOLO. With that, we will see you in our next video.
If you'd like to explore practical resources and hands-on examples, we've created a dedicated GitHub repository. It's filled with cookbooks covering computer vision, AI agents, and more. Link is in description.